Hey all you cool sabers. So I've got some bad news and some good news. The bad news is that I actually already made this video and I completely screwed it up somehow. The sound was all off and it didn't work and it was a disaster. So I have to redo it and everything's already written down on this sheet and I'm just going to kind of walk you through as best I can. The good news is I did a terrible job last time, so fingers crossed it will be better now. So, with that being said, we're going to talk about the derivatives of trigonometric functions. So, of course, we know three primary trig ratios, sine, cos, and tan, and the properties. So, you can see I've written out, this is what I'm talking about, I did a terrible job. I wrote out three properties for sine and said, hey, guess what? They're exactly the same for cosine. And it was just the domain, x is an element of real numbers. The range, y is between -1 and +1, and it's periodic with a period of 2 pi. Tan, I actually didn't say anything, and I'm not going to do it. I guess the period is only pi. Okay. Period's pi. It's got a bunch of asymptotes, so our domain is very different, and I don't really want to go through that because it's not really all that relevant. Okay. What is relevant is we do want to take a look at what they look like. So there's our sine graph. Whoops. Cosine graph. Very well drawn, you can see. I have a very steady hand. Some say I should have been a surgeon. Anyway, and finally our tan graph, where I've got our asymptotes there. And yeah, so you should be familiar with those trig identities. I've written out three trig identities that matter for us. Of course, you've learned roughly 17 million trig identities in your advanced functions course, and these two might be obvious that I would use those because those are kind of major ones. This one's a little obscure. However, it's going to become really handy when we do something later. So let's take a look at the derivative of sine and cos. So the gist of this lesson, it just sort of hinges around the fact that the derivative of sine is cos, and the derivative of cos is negative sine. Okay? Now, we can jump up here. Why not? Let's take a look at here, and I can show you sort of why that is. I didn't do this last time. Or did I? I sort of did, but I did a bad job. So anyway, it doesn't really matter. What's important here is that if I was doing the derivative, you can see that at this point, this point, this point, this point, those are all turning points. And so, of course, if we were doing the derivative is going to equal 0 at those points. Okay, what may not be completely obvious is sort of here. Oh, I should have used the yellow again. Let's switch to yellow. It's not letting me do what I'm trying to do. Well, the lesson's not worse than the last time I did it. Anyway, you can see there the slope is, it's hard to tell exactly what that is, but it is actually +1 at that point. It's easy to tell it's positive, but you wouldn't necessarily, oh, I was supposed to use green there. So that's where our derivative would lie. For here and here, okay, it's going to actually be -1. You can't really tell again. However, if I tell you that that's the tangent's at slope of 1, you can trust me, and it's obviously negative at these points. So so that's where our derivative is going to go. And where did I go? There it is. So the derivative would actually start up here and go down like that and up like that. And wouldn't you know it, that is actually the graph of cosine, right? The green line there is identical to the graph beside it. And you could do the same thing for the cosine one, and you would find almost exactly the same, except that it would be the flipped version of sine, or the negative sine. Okay? So that's it. Well, like I say, this is what you really need to know, is that and that. Those are the two most important things. Let's jump over and use them a couple times, which you can see I did. Okay. So for the first one, like all the same rules apply. We've got a product here, so we're going to have to use the product rule. The only thing that's new is that when we got to this part where I said, well, what's the derivative of sine? I now know that it's cos. For this guy over here, when I said, what's the derivative of sine? I knew that it was cos there as well. And that was it. Okay, you can see I didn't simplify either of these anymore. That's okay. You don't have to. If you're going to use it for something useful, then, you know, you're probably going to put numbers in which case there's probably no sense in simplifying it. So some people get really caught up on simplifying. It's not always useful. It's not always helpful. Okay. The chain rule applies the same though. It doesn't matter if it's sine or cos. If you've got sine of f of x, when we take the derivative of that, you'll have cosine of f of x times the derivative of f of x. Same thing for cosine, except do not, and I'll tell you right now, almost every mistake on the test for this unit is going to be people forgetting that negative there. It's the easiest thing in the world to do. I do it all the time. Derivative of sine is cos. You just instinctively think, well, derivative of cos is sine, but it's not. It's negative sine, so don't forget that. So you can see I did a couple here. Sine of x squared, we've got cos of x squared, and then we do have to remember to multiply by the derivative of the x squared. And then I jumped over to this one just because it was a little trickier. This is another thing. People like to simplify this into sine squared x. That doesn't equal sine squared x, so don't do that. Leave it like that. Sine of x. It's fun to say, too. Sine of x. Okay? And then, of course, you have to remember to multiply by cos of x. All right? So the next thing here, where all those properties, or not properties, what did I call them? Oh boy, what are they called? We just talked about it. Identities. The identities. Okay, the trig identities are going to come in handy here. So first of all, because the other thing, obviously, we said derivative of sine is cos, derivative of cos is negative sine. What is the derivative? What is the derivative of tan? First thing you got to remember is that that tan is equal to sine over cos. Okay, using that, we can rewrite the function as sine over cos, and then we can go to take the derivative of that, and we can just use the quotient rule. So we end up with cos x minus sine x negative sine x, which simplifies to cos squared plus sine squared, and then of course both of them over cos squared. So then you remember that, sine squared plus cos squared equals 1. Well, cos squared plus sine squared is the same thing as sine squared plus cos squared. So they equal 1. And then 1 over cos squared, we use the fact that 1 over cos is equal to secant. 1 over cos squared is going to be secant squared. So the derivative of tan is just secant squared. Okay? And that's it. So there's a whole other couple pages here that I want you to actually try out on your own. And then we'll take up in class, unless, of course, you are watching this as I'm recording it and are in isolation, in which case we will talk about it on the Google Classroom. So until next time, go Sabres!